Alrighty, I think we will begin. So, final exam review day today, and it's going to be a trig focus. So, we're going to start with a trig equation. Now, we have solved a variety of styles of equations for trig. Some of them have a linear feel to them, some of them quadratic, some of them involve identities. So I'm just doing one as a little, refresher. Then I have a word problem, a periodic modeling word problem, and then I have an exact value question. Okay. So obviously with trig we did, a lot of things, but I just took three, you know, a word problem and two solving style questions just to get us in the exam review headspace. Oh, sorry about that. Okay, so let's start with the solving question. Because this equation 3 tan squared x minus tan x minus 4 equals 0 has a quadratic feel to it, we have to make sure that one side is equal to 0, which it is, and now we can factor. So I'm going to just do it as crisscross. So 3 tan x times tan x is 3 tan squared x. And I'm going to try 4 times 1, and I'm going to make the 4 negative. And this would give me negative 4 tan x, positive 3 tan x, and those do, in fact, add up to negative tan x, like the middle term. So now I have 3 tan x minus 4 tan x plus 1 equals 0. And once I factored, this creates two individual equations for me to solve. I'm just going to set each bracket equal to 0. And then from each branch, I'm going to isolate for tan x. So in this first one, I'm going to bring the negative 4 over, and then I'm going to divide both sides by 3. So this is the equation I'm actually going to solve. Now the first thing I'm going to do is decide if this is a calculator or a special triangle question. So when I see 4 over 3, that does not remind me of any of my special triangles. I'll just draw our special triangles on the side here as a reminder. So we have the isosceles pi over 4 triangle. That's 1, 1, root 2. And we have the equilateral triangle that was cut in half. That's 1, 2, root 3. At the bottom, we have pi over 3 and pi over 6 at the top. Okay. And yeah, 4 over 3, obviously not there. So a few things. Refresher on our CAST rule. The CAST rule tells us where each ratio is positive. We are solving an equation where tan is positive, so that means we want to be in quadrant 1 where everyone is positive, and quadrant 3 where only tan is positive. And this is great and everything, but I need to figure out what that little alpha angle is, and I'm going to go to my calculator, and I'm just going to take a tan inverse of 4 over 3. Now, make sure your calculator is in radian mode, and that actually also reminds me, please remember to bring your calculators on the exam day. Phones do not count as calculators, obviously, and no graphing calculators either. Okay, so when I did tan inverse of 4 over 3, I got approximately 0. I didn't say how to round, so I'm just going to round to 2 decimal places. There we are. So that's my alpha angle, and in quadrant 1, x is going to equal exactly that alpha angle, because in quadrant 1, this is my angle. In quadrant 3, I have to go past pi and then add on alpha. So in quadrant 3, I'm going to do pi plus 0.93. And that's going to give me 4.07. So we have found our first two answers. And in the equation, I gave us the domain of 0 to 2 pi, so that's just one rotation. So those are my only answers for that branch. Now I'm going to go to the other branch, which is tan x equals -1. When I see -1, it reminds me of that isosceles special triangle. So I do not need my calculator to know that alpha is going to be pi over 4, because from pi over 4, opposite over adjacent is 1. Now the negative is just going to be affecting my cast rule and my quadrants. This time I want the quadrants where tan is negative. So that's in sine's quadrant and cos's quadrant, because tan won't be negative there. So in quadrant 2, x is going to be pi subtract our alpha, because we just have to remove this little slice, because that's the angle we want. And that's going to be 3 pi over 4. There's another answer. And in quadrant 4, we need to make our way all around, almost reaching the whole 2 pi, but not quite. We have to remove a slice of pi over 4. And that's going to give us 7 pi over 4. And there it is, a refresher on cast rule, your alpha, your special angles. Now, like I said, this type of question could have been linear from the beginning. It could have been quadratic, but you had to use a trig identity to make it all in terms of the same ratio, or it could have involved a double angle, whatever it might be. And when you're working through the exam review, I put a variety of trig equations to make sure you're hitting each style. Okay, but this should warm you up with the solving. Any questions about the solving before we go to a word problem? All right. So our word problem. Now, we did a variety of styles of word problems. A lot of them were wheel related, like a Ferris wheel, a water wheel. You could have tides, things that fluctuate up and down. So let's take a look. Kira went for an indoor bike ride in the morning. As she pedals, the height of her right foot above the ground moves between 12 and 28 centimeters off the ground. So this right here is reminding me of max and min values. So a maximum of 28, a minimum of 12. This is going to allow me to find the central axis value, so the midline, the amplitude. Okay. Kira sets the resistance on high, so in 1 minute she pedals 50 times. Create a sketch to represent the height of Kira's right foot off the ground with reference to time in seconds, assuming her foot starts at 12 centimeters. Include at least one full cycle, then write an equation to model this scenario. Okay, so because I already have my max and mins, I'm just going to start off by labeling a few things on my scale. So I'm going to have time in seconds and height in centimeters. So I am going to make little therefore statements, let statements for myself, because when I write my equation, it's going to be in terms of h and t. So I need to remember to do that at some point. Now, let's say this is my minimum, this is my maximum. That's all I really need to label there. And I know that her foot is going to fluctuate between these values, which means my midline is going to be at the average of 28 and 12, right halfway. So if I add 28 and 12, I get 40, and 40 divided by 2 is 20. So 20 is my midline. Now, personally, I've always liked highlighting these 3 lines. It gives me a nice guide when I have to create my function. And once I have these, it would also be helpful to get my amplitude. Now my amplitude, remember, is just the distance from your midline up to the max or down to the min. So I can see visually here that it's 8. But you could also do the maximum minus the minimum, so 28 minus 12, and then take that answer, which is 16, and divide it by 2 to get 8. These values here are going to be important for our equation creation, but right now we're just trying to sketch. Now, we were told that Kira's foot is starting at 12 centimeters, so at time 0, the height is 12. Now I need some information about the period so that I could figure out how to label my time scale. Okay, so let me write period here. And I did have some information about the time. In 1 minute, so in 60 seconds, she pedals 50 times. So I need to take that 1 minute, which is 60 seconds, and I have to split it into 50 little chunks. And then I want to know what the length of each chunk is, which means if I want my period, I'm just going to divide 60 seconds by the 50 times. That means there are 50 cycles in 60 seconds. So that's 6 over 5 or 1.2. So for my sketch, I didn't specify how many, I wrote include at least one full cycle. Okay, so I'm just going to space this out nicely. I'm going to have my cycle end here. Now we know when we draw a sine or a cos function, whatever it might be, every key point occurs a quarter of a cycle. So I need to take that period and I'm just going to split it into 4 pieces. And remember, it's 4 pieces because we have 4 quadrants. So if my period is 1.2, halfway is 0.6, halfway from that is 0.3, which means it should be 0.9 here. And now that I've split it off, I know that the first cycle should end after 1.2 seconds, and now I'm just going to fill in the blanks to create that nice little wave. If I wanted to do another cycle, I could. Every key point is occurring every 0.3 seconds. So now I have a nice sketch. I just need to get that equation going. So I'm going to make a little note here. Let t represent time in seconds, and let h represent height in centimeters. And my equation, h at t, is equal to. So with these questions, we get to pick if we want it to be sine or cos, and it's going to depend on what you choose as your start to the cycle. Now, any of these points can be a starting point. It doesn't matter. I'm going to pick the easiest one, which is on the y-axis. It's a nice point on the minimum, which means I can avoid a right-left shift. So because I'm choosing the minimum, that means this must be a cos function, because cos typically starts at a maximum. But because this one's starting at a minimum, that means cos must have been reflected over the x-axis. So I'm going to add a negative out front. Now we need the amplitude, which we already calculated to be 8. So the start of my equation is negative 8 cos. And then inside my bracket, there's no right-left movement, but I need that k value that will make the period be 1.2. Now a reminder, to find the k value, we're just going to take 2 pi and divide it by our period. Now I don't want to have a fraction and a decimal, so I'm going to do 2 pi divided by 6 over 5. And remember, when we're dividing by a fraction, we're actually multiplying by its reciprocal. So I'm actually doing 2 pi times 5 over 6, which would be 10 pi over 6, which reduces to 5 pi over 3. So that's my k value, okay? Remember, your k value represents the horizontal stretch or compression. So this function, the original cos function, must have been compressed because the original period is 2 pi. We have to compress it to make the period 1.2. And that's what this k value of 5 pi over 3 will do. So 5 pi over 3 times t, like I said, no phase shift, no right-left movement because we chose a starting point on the y-axis. If I chose this point here, then I'd be using a sine function with no reflection, and I would need a phase shift to the right 0.3, which is totally fine. I would accept that. But to me, why would I use a more complicated equation that has more transformations involved? And then finally, I need the midline at the end, which is plus 20. So there it is. I've shown my cycle, like with my sketch. I've shown important properties on the side to help me get my equation. I did my let statements, and then I have my equation. So there it is. Okay, now remember, again, variety of questions for periodic modeling, Ferris wheels, water wheels, tides, and again, when you're doing the exam review, I have a variety of questions in there, so you hit the various styles. My final question here, I wanted to include at least one type of trig identity in this mini review. So we're going to do an exact value question that involves the compound angle formulas. I can't remember if I said this earlier this week during the Google Meet session, but I posted it on D2L because I was reminded about this. But I will be providing the trig identities on the exam. They will be on the cover page. So you don't, I mean, if you're doing practice, you should know them, but when you're in an exam, maybe you're nervous, you forget it, you'll have it there to double check. Okay, so we need to determine the exact value of cos 29 pi over 12. Obviously 29 pi over 12 is not a special triangle angle, so I need to find the sum or difference of two special angles that give me 29 pi over 12. So what I'm going to do just on the side here is try to add two fractions with a denominator of 12, and hopefully when I reduce those fractions, they become a special angle. So something over 3 or 4 or 6 or 2, something like that. So to get 29, I can try, I could try 2 pi plus 27 pi. 2 pi over 12 is pi over 6, so that's definitely good. And 27 pi over 12 is 9 pi over 4. Now 9 pi over 4 is, beyond quadrant 1, but that's okay. I can still figure out the quadrant. And 9 pi over 4, because it's over 4, I know it's a special triangle. So now I can rewrite this value as cos of pi over 6 plus 9 pi over 4. And this is not the only combination you can use. There's lots. This is just what I thought of in the moment. Okay. Now, this is the addition of two angles. So just a reminder, cos A plus B is equal to cos A cos B subtract sine A sine B. And in my version here, pi over 6 is A, 9 pi over 4 is B. So I'm just going to set everything up. Oops. And I'm just going to bring those special triangles from above down for us. There we are. All right. So cos pi over 6, I can evaluate no problem. Looking at the special triangle from pi over 6, adjacent is root 3, hypotenuse is 2. So root 3 over 2. Remember, anytime special angles are involved, you should be showing those special triangles on your exam. Otherwise, it just looks like you used your calculator, because there are calculators that give exact values. Now, when I go to cos 9 pi over 4, I know I'm going to use the pi over 4 triangle, and from that one, adjacent is 1, and hypotenuse is root 2, but I have to think about what quadrant 9 pi over 4 is in. Now, we know a full rotation takes me to 2 pi, and 2 pi is 8 pi over 4. And the angle 9 pi over 4 is actually more than that, just a little bit more, just an extra pi over 4, which means 9 pi over 4 is actually still in quadrant 1, just a rotation away. Another way, if visually you don't like thinking of it like that, remember you can always add or subtract 2 pi, like a full rotation to any angle, to get a coterminal angle. So an angle that is in the exact same position, just a different rotation away. So if I were to do that, if I took 9 pi over 4 and subtracted 2 pi, I would get pi over 4. So the ratio of cos 9 pi over 4 is going to be the exact same as cos pi over 4. Either way, it's an angle in quadrant 1, which just tells me my ratio will be positive. Okay, so now I'm going to go to sine. Sine of pi over 6 is here, opposite is 1, hypotenuse is 2. And then sine of 9 pi over 4, or pi over 4, is opposite is 1, hypotenuse is root 2. Now, before I do my multiplication, I do want to rationalize the denominator of 1 over root 2. So I'm just, reminder, multiplying top and bottom by root 2, because we should not have radicals in the denominator. And once we're here, I will multiply my numerators, multiply my denominators, and then subtract the fractions. Root 3 times root 2 is root 6. 2 times 2 is 4. Subtract 1 times root 2 is root 2. And 2 times 2 is 4. Lucky for us, it's already a common denominator, so I will just unite my fractions for my final answer. And there we have it, an exact value using our compound angle formulas. Okay, so that's kind of it for our trig-specific exam review. Okay, obviously I didn't go over everything, I just did a few key things. I'm gonna go to our exam review, and just like I did the other nights, I'm gonna highlight the trig specific things. Now at this point you should be able to finish the rest of the questions. So in terms of graphing, questions 8 to 11 are all trig related graphing questions. I put a cos, I put a sine, I put those reciprocal functions as well. Then, as I said earlier, there's so many different styles of trig solving. Questions 20 to 26 have a variety. Factoring, sometimes identities are involved, that kind of thing. Okay. We didn't do any inequalities for trig, so we don't have to worry about that. That's why there's no questions there. And in terms of word problems, I put a Ferris wheel, I put a tide question to give you a bit of variety. Symmetry for cosecant. And then we've also done trig identities, equivalent trig expressions. Here's that exact value style question. More compound angle, double angle. And then the last two questions are not from unit, from trig. They're from our final unit back in December. And that one I'm not doing a review for, just because it should be the most fresh in our minds. Okay, so there's the review for trig. Okay, any questions for me about the trig review that I went over, or if there's other styles of questions you want me to do, let me know. So I'm just going to stop the recording here.